Hey, Bill here. I wanted to give an update to the Introduction to Digital Computer series of videos. When I started creating these videos, I wanted to show how to build an 8-bit digital computer entirely from NPN transistors. Now, of course, my plan was to release a video about once a month, but over time I realized the usefulness of demonstrating the circuits in action. So I put together these quick videos showing the various circuits we discussed in action. As our computers got more complex, the sample circuits have gotten more complex. And last time we showed a working arithmetic logic unit in action. Since then, I've taken the liberty to build the accumulator latch circuit. Recall from the last introduction video that an accumulator both reads and writes to the arithmetic logic unit at the same time, so it contains an extra set-reset flip-flop beyond that of a D-latch, so that it can internally store the results and then present them to the output in such a way so that we don't get weirdness in the results. Now, of course, why build one of them when you can build 8? And I've tied them together in this box behind me to the arithmetic logic unit. I'm also in the process of building these 1-bit register circuits. They lack the extra set-reset latch of the accumulator, and as of this video I have built 12 of these boards. I need to build another 20 in order to show the entire system from our 4th video in action. So this is the circuit that we have thus far. We have the arithmetic logic unit here. We have the boards representing our accumulator here. The yellow wires are our bus. The rest of the wires here are our control signals. We can demonstrate this working by setting the control signals for addition, then inputting a value into our bus, say 10. The accumulator is showing the results of the bus input 10 plus 0 from the accumulator. Now when we pulse the read signal to our accumulator, when it goes high, the value is latched to an internal set-reset flip-flop. When it goes back low, the result is then carried to the output of our accumulator, which is 10. Now, because it's outputting 10 and they still have 10 on the bus, our accumulator is now showing the result 20. But the important part is that we've successfully added 10 plus 0 equals 10 into our accumulator. If we pulse this a second time, we get 20. 1, 2, 4, 8, 16, and 4 is 20. Of course, we're reading 10 in our input line, so this should be 30. 1, 2, 4, 8, 16, and 8 is 24, and 4 is 28, and 8 is 30. Now we can subtract by 10. And of course 20 minus the input of 10 is 10. If we pulse our read, that'll get set into our accumulator. And of course 10 minus 10 is 0. We can set for left shift. Each time I pulse, the results is shifted to the left. We can set for right shift. And each time I pulse, the results are shifted right. We can set for not. Remember, the output of our arithmetic logic unit is on if the input is off, and vice versa. And that's our accumulator and our arithmetic logic unit in action. Thanks for watching.